So today we will discuss about one of the most important topic, that is about performance tuning. So as a developer, you should be knowing like what are the best practices you need to follow while coding, and also in case if there are any performance issues, you should be in a position to debug it and do the performance tuning and all. So we'll see few features what all we can do in case if there are any bottlenecks and if there are any performance issues in your workflow and all. Okay, so first of all, performance tuning. When we go for a performance tuning is if there are any bottlenecks in your flow, in your workflow. um, so we'll consider one scenario. So consider you have a source, okay, which is either a table or a flat file. So we'll consider this as a source, which is a table. Okay, so you are getting some 10 million records every day. You might be getting a 10 million records from this source, which you are supposed to load it to another table. So in between you might be performing a number of transformations, formatting the data and all. Okay, so in between you might be applying any transformations and all. So if this is a scenario, so assume like you have created a workflow for it. Okay, so you have created a workflow, and in the workflow you have created a session, and within from session you are calling a mapping which is performing this requirement. So this is supposed to run every day. So assume like at every day at 7 a.m. EST, IST, this workflow has to run. So you are scheduled it to run at 7 a.m. IST, and they have provided you a SLA. So the team which provides you the requirement, right? They will always give you a SLA also. That is called a service level agreement. But that is nothing but the time by when they expect the data in the target. Okay. So if assume like the batches complete by max 7 a.m. and the data will be available in the source by 7 a.m. So your workflows will be scheduled to run at that time. So they might provide you a SLA say like by 7:30. Okay, by 7:30 a.m. the data should be available in the target, so that their processes will run and process the data. So this is the SLA they have provided. So assume you have done the coding. So how much time you have, guys? So you have 30 minutes of time to complete your workflow. Okay, so since it's a used data, so assume you have done the coding and all, you are tested with respect to the data quality, the requirement, everything is working fine. So now after that you see that this workflow is running for me for 45 minutes. Okay, so it's almost taking to 45 to say like 1 hour. So this workflow, it is taking every day when I run it, it is taking 45 minutes to 1 hour. That means there is some performance issue as per the SLA they have provided. So they want me to complete this flow within 30 minutes, but as per my coding, it is taking almost 45 minutes to 1 hour. So in such cases, we perform some practices to check where we have issues, performance issues, and how we can overcome it. Okay, and there are few best practices which you can blindly follow whenever you start with your coding. So it will always improve the performance. Okay, so that we'll check today. So the first point here is to identify the bottleneck where we have a performance issue. So in order to find out that, we have two types. One is with the by analyzing the session logs what you generate. So when we run the workflow, it creates as a session logs, right? So with the session logs we can check if there are any performance issue. So what we'll do is we'll take a simple example here just to see that. So we'll consider one flat file as a source. Okay, we'll consider this EMP data. So what I'll do is, just to make it, to get some extra records, I'll just copy the same data so that we get some more records in our source. Okay, assume we have some 1,000 plus records here. So I'll just use this file as a source. Okay, it's the same employee data. So I'll take that source here, flat file, emp data. So assume we are loading it to a target table. That is my emp target. Okay. Okay, this is my mapping. To run it, we'll go to our workflow. Okay, let me create a new session. Load UMP data. Okay, so let me connect it to start. Okay, so this is my session. So here I'll give the path of the source file. Okay, I have given a file as a target. I'll replace it with the table. Okay. Okay. So now if I run this workflow, so I can see the session here. So the session is running and it is completed. So with the help of session logs, we'll be able to check few things like whether there are any performance issues or not. That is the first method, using session logs by analyzing the thread statistics. So there is something called as thread statistics, which we can get within the session logs. In Informatica, when we run a workflow, there will be three types of threads which will be created. One is called as reader thread, another one is writer thread, third one is called transformation thread. By default, whenever you run a workflow, it will create you three threads. Reader thread. This reader thread is responsible for extracting the data from the source. That's why it is called as reader thread. It takes the data from the source. Writer thread is something which loads the data to the target. And transformation thread is responsible for the transformations, whatever you are doing within your mapping. Okay, these are the three threads. So if I go and check the session log here, get session log, and if I find something with thread, you can see this. Okay, let me create one transformation also, so since there are no transformations in the mapping, it has just created me the reader thread and the writer thread. So we don't see any transformation thread because we don't have any transformation. So if I simply create one transformation like or let me have an expression. Okay, let me take the logs now. Okay, can you see the three types of threads here created? One is the reader thread, Then we have something called thread transformation. Okay. So whenever you run your workflow, so you get three threads: reader, transformation, and writer thread. What happens is, so we can get these thread statistics. What are those statistics? We can get something called as runtime of the thread. What is runtime? Amount of time the thread was running. That time I can get it. Ideal time, amount of time the thread was idle. For each of this reader, writer, and transformation thread, I can get these thread statistics: runtime, idle time, and busy time. Busy time is the percentage of runtime where the thread was not idle. Okay. So by getting these thread statistics, if any of the threads, also we get something called as busy percentage. Okay. If any of the threads busy percentage is greater than 100, then we say there is a bottleneck at that place. In case if the reader threads busy percentage is greater than 100, we say there is some bottleneck, that is there is some performance issue while reading the data from the source. If the busy percentage of writer thread is greater than 100, we say while loading the data to the target, there is some performance issue. If transformations thread a busy percentage is greater than 100, the transformations, the formatting what we are doing with the help of transformations, there is some performance issue at that point. So that we can make it out with this thread statistics. If you see the logs here, it says thread reader created for the partition point sq emp data. This is my source qualifier. So the reader thread is created for my source has completed. It says the total runtime was insufficient for meaningful statistics. That means since the source records were the source data was very less, it was not able to create any meaningful statistics. Since it ran very fast, it completed quickly, it was not able to create any meaningful statistics. If you are dealing with huge data, then you'll get the statistics what I explained here. Okay. Same thing it says for transformation thread and writer thread. Okay, so what we can do is, let me try to add some more records so that we can get some statistics. Okay, so this should be fine. So let me rerun my workflow again with I've added some more data. So it has taken some 93,000 records and loaded. Now if I go and check the log, so now you can see the statistics very clearly. Okay, so if you see, first it says for the reader thread, for the source has completed, it says the total runtime, how much time it took to run, and in that how much time it was idle, and this is the busy percentage I was talking about. Okay, so in case if the busy percentage is greater than 100, then we say there is some bottleneck, there is some performance issue. Here the busy percentage for reader thread is 22, so there is no issue. Likewise for transformation thread, it is just 4, and for writer thread it is 100. So still it is 100, not greater than 100. So if you see, if you observe, we have taken around 93,000 records from source, that is a flat file, and we are loading those records into a target, which is a table. So while reading the data from the file, the busy percentage is only 22. The same data, when I'm trying to load it to a table, it is around 100. So that's why we say reading or loading the data to a flat file is quicker than a table. Either it might be a source or a target. If you compare, if you take one flat file as a source and also a table, you add same amount of data in both that file and a table, and try to extract the data from them. So Informatica, it will be able to extract the data very quickly from a file than a table. That's why if you can see, though I'm taking the same data and loading to the target, the busy percentage is quite more here. But still, this is fine because the busy percentage is not greater than 100. In case if it is greater than 100, then we say there is a performance issue. So it is 100 and it completed very quickly. Okay. So using this thread statistics from the session logs, this is one way of identifying if there are any performance issues. So now I checked here, so there was no issue for me. Then what else I can do? So the second approach is called as Informatica recommended approach, which we normally follow. So what we do is, in that, the first thing is we assume that there is a bottleneck at source or target or at some transformation. We assume there is a bottleneck and then we try to test it. Okay. So what I'll do is, first step is check if there is a bottleneck at target. So I want to check whether there is a bottleneck, that is performance issue at the target while loading the data to the table. Okay. How can I check it? So I can do the testing using some test sessions by running some test sessions. What I can do is assume if your target is a table. So you are loading a data to a table as I'm doing now. So in order to perform some test runs, what we'll do is we'll replace that target, which is a table, with a flat file. Okay. So your requirement is to load the data to the table only, but just for test run, just to identify whether the performance issue is while loading the data to the table, what I'll do, I'll replace it with a flat file. If the load time is reduced, then there is a bottleneck at target. That means, so this is my actual flow. This is my actual flow mapping, which is extracting the data from a file and loading to a table as per the business requirement. So just now to test whether there is an issue at the target while loading the data to the table, what we'll do, we'll perform some test runs. So to perform the test runs, we will replace this target, which is a table, with a flat file. But normally we won't do it in our actual mapping where we have done our coding. What we'll do, we'll create a test mapping for it. So maybe I can just say like, so the same mapping you can take and drag and drop here. So it will create a copy of it. You just rename it accordingly. Say like performance testing something. Just for testing purpose, you are creating it instead of modifying your actual mapping. Okay, this is the same mapping what I have. So in this mapping, what you will do is, so you will replace this target, which is a table, with this. So you will create a same target, the same structure of the table as a flat file. Okay, now, so this is my target flat file. So the structure of the table and this flat file are same. So the similar target you will create, which will be a flat file. Then you will load the data to that flat file here. Okay. So this is your second mapping, the test mapping. Then what you can do is, if you just want to test it, either so you will create one more. You can create one more session, that is something, a test session. Okay, it's already there. Okay, so you'll select your test mapping. So run both of this in parallel now. Save. Okay. So what we are doing for both of this, the source is same. My actual target is table. In the test session, I'm loading it to a flat file. Now you can run both of this in parallel. Okay. Okay, I have to provide the file name. Source. Okay, target file, let it create here. Not checking that. Start the workflow. See, my test workflow actually completed 1 second before my actual one. That's what I was saying actually. So processing of records with flat file is much faster than the table. Okay. So now what I did, I have done it, created a test session and mapping, and I have replaced it with my table. Okay, target, instead of target table, I have used a target flat file. So you can do this test run, and if you see the load time is reduced. In my case, it was just 1 second, but in real time cases, if there is really a bottleneck at your target, so then the load time, it might be differing from 5 minutes, 10 minutes, 15 minutes, 20 minutes and all. So if there is a much time difference, then you can say, okay, there is this performance issue is at the target level where I'm trying to load the data. Okay, that conclusion you can get it with this test run. So if you see there is a bottleneck, that means if there is much time difference, so then what are the solutions? So you can't just replace the target with the flat file, because the requirement is you need to load the data to the table only. Just to check whether the issue is at the table level, we will do this test run, but we can't recommend them, see, issue is here, performance issue, so I won't load it to table, I'll load it to flat file. That is not done. So because the requirement is we have to load the data to the table only. Then what are the solutions we can go for to reduce that performance issue? Solutions are like, check any indexes exist on the target level or not. That is indexes. So you are loading the data to this particular table here in the database level. Are from my target. So this is the table where you are loading the data. So you can check whether there are any indexes existing on this table. So at the database level, they might have created the indexes, so that you can check. So you can check it using this query. Select star from all indexes where table name. So if there are any indexes created, it will list down those indexes. So in my table, there are no indexes created. So indexes are basically created so that it will improve the performance when you are extracting the data from the table. Okay. So if there are any indexes created, so actually it takes time. It takes some time to load the data to such tables. So that's why. So we first check whether if there are any indexes created. If there are any indexes, then what we will do is, if indexes exist, drop indexes before load and recreate those indexes after loading using pre and post SQL. So this is created at the table level, so that whenever you want to extract the data from the table, there won't be any performance issue. So, but it is creating me issue with while loading. So what we do is, normally in our pre-SQL, that is, this is my source here in my session source. If you go, there is a pre-SQL and sorry, this is my target. Yeah, in my target, if you go, you can see the pre-SQL and post-SQL. So in the pre-SQL section, you will drop those indexes using this query, drop index name. If there are some 10 indexes created on the table, so one below the other, you can write the same query, okay, separated by semicolon, and give that particular index name. So in the pre-SQL, it will drop the index. What it will do, before starting the loading to the table, it will drop those indexes. So when it start loading the table, there won't be any indexes in the table. So the loading will be faster. And once the loading is completed, in my post-SQL, I will recreate those indexes. Whatever I have dropped earlier, I can recreate those indexes. So this is one solution to improve the performance. Second thing is, go for bulk load. What is bulk load? If you see in the target here, again, so target load type, there are two types of loads. One is normal load and one is bulk load. Okay. So if we use bulk load, it will improve the performance. Again, if you want to go with the bulk load, there should not be any indexes on the table. So if there are indexes, you have to drop in the pre-SQL and recreate them in the post-SQL. So if we go with the bulk load, even this will improve the performance. Why? Because go for bulk load when we insert to table in Oracle. So this is Oracle database functionality. We can we can load the data to the Oracle tables in two methods, with bulk load or normal load. What happens is, when we insert the data to the table in Oracle, it writes at two places. One is at the data file level and one is at the read or log files. So whenever we insert a data to our Oracle table, it writes at two places. One is data file and another one is called read or log file. If we use bulk load, it won't write to read or log files. So that time taken to write the data to the log files will be reduced if we go for bulk load. So it will improve your performance. Okay, so you can use this bulk load option. So make sure you drop and recreate the indexes when you use the bulk load in your pre-SQL and post-SQL. Even this will improve the performance. Again, still you want to improve the performance, means you can increase the commit interval. So in your workflow properties, we have the commit interval. So by default, it will be 10,000. If you are processing some used records, you can increase this commit interval. So what it does is, for every 10,000 records I insert into the table, it will perform a commit on the table. So the more the records, more the commit operations will be. So you can improve you can increase the commit interval time here. Instead of 10,000, you can say 1 lakh. So again, it depends on your the data, how much you are processing. Okay. Even so, by reducing that number of times you want to perform the commit, will improve the performance. So that's why we say, in case you can also always go and improve your commit type. So okay, this is another method. Increase the commit interval. Still, if there are any issues, the last thing what you can perform is database table partitioning. At the Oracle database level, on the table, target table where you are inserting the data, you can perform the partitioning. So there are different types of partitioning available in the Oracle. So you can do the partitioning on the database table level, not at the Informatica, at the database table level. Even this will improve the performance. Okay, so these are the different solutions we have for to in case if there are any bottlenecks at the target. Okay, so assume like you checked at the target level, so you replace the table with a flat file, but the time taken was almost same like we did now. So it was just a 1 second difference. So it was just 1 minute or 5 seconds difference means. So actually there is no issue at the target level. Then you will go to the source level. You will go and check if there are any issues at the source where we are extracting the data. Okay, then what we have to do. So I think it will disconnect in a minute now. So once it disconnects, we'll quickly connect and we'll continue. Okay. Mapping is doing, it is extracting a data from a table and loading a data to the table. So this was my actual mapping, right? What I'll do, again, I'll create one mapping here. So in this test mapping, again, I won't change the flat file, so I will keep it as it is. That so I'll take whatever was there in the existing mapping. So in my test mapping also, I will have the same thing. Okay. Even in my test mapping, it is extracting the data from a table and loading to the table only. But in between the, so as of what I will do, one change what I will do is post my source qualifier just after my source qualifier. If there are any transformations also after the source qualifier, before any other transformations, just after my source qualifier, I'll create one filter transformation. Okay. I'll move all the ports from my source qualifier to this and from my filter to the next level of the pipeline. In my case, it is a target. If it is other mappings, there might be other transformations. And in my filter transformation, I will give the condition as false. When I say false, what happens? None of the records from this filter transformation will move to the next level of my pipeline. Okay. So in my actual mapping, data will be extracted from the table, then it will go some transformations. If there are any transformations, then it will load to the target. And in my test mapping, what happens? Data will be extracted from the source. That's it. It will go to the filter transformation. That's it. From filter transformation, none of the records will be moved to the next level of my pipeline. That is because I have given the filter condition as false. It will filter out all the records and it won't pass any records to the next level of the pipeline. Then with this change, I will run both of my workflows again. Okay. I will run my test workflow also and my actual workflow also. And I will check the time. That is, so after source qualifier, add a filter transformation with condition as false. Okay. Then what happens? If I mark it as a condition as false, in my test mapping, none of the records will be moving to the next level of my pipeline. They will all be filtered at my filter transformation only. Then what I can check? If workflow runs for the same time, so if both the workflows run for the same time, that means then there is a bottleneck at the source. If both the workflows run for the same time, then we can say there is a bottleneck at the source. Why? What was my first workflow? This one. It was assume this mapping, it is extracting the data from the table, loading to and also loading to a target. It was taking 10 minutes. Now, even my test mapping, which just extracts the data from the source, and it is not even loading to the target because filter condition is false. Even this mapping is taking 10 minutes. If both the mappings are taking same time or the time difference is very minute, okay, then we can say yes, it is taking a lot of time while extracting the data only. While extracting the data from the source itself, it is taking a lot of time, right? So in such way, in with such testing, I can say yes, there is a bottleneck at the source level. Okay. So what I have to do? I have to add a filter transformation with condition as false just after the source qualifier. And in my test, this I have to do it in my through test session. You need not to touch your actual coding mapping. So you can just create a copy of that mapping and do all this testing. Okay. And here, if workflow runs for the same time, then I can say there is a bottleneck at the source. Then what will be the solution? If there is a bottleneck at the source, what I can do? So if the source is a table, I can go and create indexes on the source table. So always, if we have indexes on the source table, it will help. It will improve the performance for the select query, right? So I can go and create the sources, indexes on the source table on columns which are used in where clause and joins. That is, this indexes I can create at the database level. That is one option. Second is check whether we have used necessary filters and join condition in source qualifier query. Again, this is very important. So if my requirement was like I have employee table here, okay, and I have a target table. So if my requirement is to load only in this employee table, I have employees with department 10, 20, 30, 40, and so on. If my requirement is to load only the employees with department 10, then while extracting the data from the table itself, I can write a filter query to get only the employees with department 10. And only those records will be extracted into my Informatica. There on those records, I will apply the transformation. I need not to extract all these records. If I don't apply this select filter condition, then it will extract all the unwanted data also, and time will be wasted in extracting that unwanted record. So check whether we have used necessary filters and also the join conditions. Based on join conditions also we can filter out some unwanted data records, right? So in the source qualifier query, that is the best thing. If it is a table, if the source is table, I can use the filter queries and joins on the in the source qualifier. In case if it is a flat file, as soon as the source qualifier, I can use a filter and I can remove the unwanted records which I don't want in further in my uh, mapping further. Okay, I can use a filter transformation if the source is a flat file. That is one thing. Then the last one more approach can be I can use the ints in the source qualifier queries. Wherever I am using a source qualifier, in my source qualifier I can use some SQL ints also. So but this approach is not much recommended. So not only in Informatica, in real time, if you have if you want to tune some SQL queries, using ints to tune the queries is not recommended unless until you have a thorough knowledge on the data on which you are working. Okay. So what happens is, if you are using a hint, so assume you are working on an employee table, and you know, if you are very much aware that this employee table won't change or in future and all, then you can go with the hints to improve the performance of the query. But if you are not aware of the table data, it is not recommended to use the hints. Why? Because these hints at that particular time it might improve the performance, then in future it might degrade the performance also. So if the table is having 100 records, for these 100 records, the whatever hints you have used in SQL might be uh, good in performance. But in future, when the records increases, if it becomes 1,000, the same hint might degrade the performance also. Okay, that's why it is always not recommended to use the hints for performance tuning of the queries until unless you have a full knowledge on the data. If you know the data won't change in future and all, then you can use those hints and do the tuning there. Okay, this is what these are the solutions which can be used to remove the bottlenecks at the source in case if there is a bottleneck at the source. Then, so as I told, we had three threads: reader thread, writer thread, transformation thread. So we saw if there is a reader thread, that is nothing but the source. If we have bottleneck, what we have to do? Writer thread, that is target, what we have to do. Next is transformation. Check if there is a bottleneck at transformations. So if there is no bottleneck at the target and source, then obviously we have performance issue or bottlenecks at the transformation. So what all things we can do to improve the performance at the transformations level is, for few transformations we can do the performance tuning. That is, for first aggregator we have to use the sorted input. Always whenever you are using aggregator, you have to use the sorted input only, then only it will improve the performance. In some cases you can go for incremental aggregation also. I think we have discussed all these two already. So what happens in the, why we have to go with the sorted input? If I have records with the department number 10, 20, 30, so these are the records which are coming from the source table. Okay, I have an aggregator here. So if I have not sorted the data on department number and use the sorted aggregator transformation, it won't do the aggregation until unless it gets all the records from the all the records for all the departments. If I have used a sorter, if I have used a sorter in between the aggregator, what happens when I use a sorter? How these records will be sorted? It will be like 10, 20, 30, 40. Department employees with department number 10, all the employees with department number 10, then all the employees with department 20, 30, and 40 will be there. So what happens when aggregator get all the employees with department 10, it performs that group by function. It performs the aggregation. It won't wait for other employees with other departments. So as and when it gets that particular group of data, it will perform the aggregation. That's how it will improve the what performance. Okay, incremental aggregation, again it will save the previous aggregation whatever it has done. Okay, in that case, if I say I should not be sending the same records again. Okay, it will save the previous aggregation whatever I have done, and based on that aggregation it will sum up the for the new records it will sum up with the previous aggregation data. That is the incremental aggregation. So whenever you go for aggregator transformation, keep in mind you have to pass the sorted input only. So that will really improve the performance. Hello.
Sandesh,
Okay. Yeah.
your voice is not a bit clear for me.
Hello.
Yeah, it's okay now.
Okay. Okay. So whenever you use aggregator transformation, go with the sorted input. Again for the joiners, same case. You have to use the sorted input only. Okay. Second, so reason being the same. So once it gets that group of records, it will perform the join. It won't wait for all the other group records to come to that join transformation. Okay. You just create some join transformations without sorted input passing to the joiner transformation, then add the sorter and run it again. You can really see the difference. Okay. And second thing what you can do is mark source. In the joiner what we have two types. It can be a detailed source and it can be a master source. Always mark source with less data as master. Why? Because cache file will be created for master source whenever. So in joiner we can there can be only two sources, right? One can be treated as a master source and one can be treated as a detailed source. So it's always good to mark. I can mark any of the source as master, any of the source as detailed, but best practice for performance is mark the source with less data as master, because for master's source it will always create a cache file. That's the reason we have to make a source with less record as master. Again, that will improve the performance. Then lookup. I can use the lookup override to get only relevant records for lookup as it creates cache. So we know that lookup transformation creates caches. Either it can be a static cache or a dynamic cache. So it creates a cache. So in my lookup transformation itself, where is my lookup? In my lookup transformation, in my properties, in my lookup SQL override, I can just get only the relevant records. I can use where conditions and filter out the unwanted records here, so that it won't create the cache for those unwanted records. Okay, that will save the time for creating the cache, hence it will improve the performance. Condition operators first should be equals operator followed by other operator. Again, it is to just to discard the unwanted records only. If you are using in the condition section, we can use any of the operators, but always make sure you are going with the equal operators at the top, then with greater than, less than, or all those. So because at the top only I can filter out as many as records I can. So that will again improve the performance. It will reduce the records which will be created in the cache. Then use persistent cache wherever possible. So if I use the persistent cache, what happens? I need not to create the cache again and again. Once the cache will be created, my next lookup transformation will use the same cache. Instead of creating its own cache, it can use the previous cache which was created. So it will reduce the time. It will save the time for creating that new cache again. So we can use the persistence caches wherever possible. So these are the some tips for performance tuning for lookup transformation. Then router and filter. Numeric comparison is faster than character or string comparison in group or filtered condition. So assume like you have a data with country name and country code. Okay, country code it is like 1 2 3. For India it might be 1, for UK it might be 2, like that. And country name is a string, right? So it is always better to have numeric comparison. Okay, because it is faster than the string comparison. Okay, if I, instead of saying if country name equals to India, I can say if country code equals to 1. That will be more faster. That comparison, numeric comparison will be more faster. Okay. Then in the expression transformation, use variable ports for repeated logic. Okay, avoid data type comparison. If it is really required, you have to do it. There is no other way, but try to avoid it if it is not necessary. Then unchecking unnecessary ports which we don't use, no need to use them. Numeric comparison is faster. Again, same thing. Use operators, then functions. then use decode function instead of nested if. Instead of using the nested if, we can go for the decode function. Okay, these are the some of the performance tuning things we can follow out for the transformations. Okay, so again, they will be asking you on the aggregator joiner, so they will say what all steps you will take to do the performance tuning. For the transformations, if they say, you can say these things. Okay, again, if you want to start with, you can say like, first thing is we have to identify the bottleneck, and how we can identify two ways: one through the session log, second through the RM, trial and error method, for target, source, and for the transformation. But these things you can follow it while you do the development itself, so that you need not to add these things again. And what else? Yeah, last thing is you have to make sure tracing level is normal. Everywhere the tracing level will be there, right? For each of the transformations also, tracing level. So this is how the logs will be created. If you give verbose initialization, verbose data, logs will be created for each of the records. So for testing purpose, you might have changed it to get the detailed logs if there are to debug something, or data to debug some errors and all. You might have changed the tracing level to verbose data or verbose initialization to get the detailed session log. So make sure before moving it to the next level, so everywhere the tracing level is normal only. So if you make it verbose data, it will keep running. It will reduce the performance again. Okay, that is one thing. And these things we have already seen. Caches in Informatica, data cache and index cache we have. Okay, these are not relevant here. So we have created one image, right, for this. Just remove it here. Okay. Then apart from this, these are all at the mapping level what I can do the performance tuning. Apart from this, we can do the tuning on the session level, but this is not really recommended. Okay. One thing is we can change the DTM buffer size. DTM stands for Data Transformation Manager. Where is it? In the session level, I can go to the properties, config. Yeah. See, we have something called as DTM buffer size. Here it is auto. So what happens? One is DTM buffer size and default buffer block size. What is this DTM buffer size and all? So when we run the mapping integration service, by default it will assign some buffer size for the for processing the record. It will be auto. Okay, in case at the start of the session run, it will allocate this much of buffer size, some memory, okay, to process the record. In case that memory is full, if I have selected it as auto, in during runtime only, it will allocate more memory to it. Okay, so that allocation might take some time. So in case the memory whatever was allocated at the beginning of the session is full during the session run, then it will auto allocate, extend that memory whatever was allocated, it will extend it again. But for that extension it might take some time. So they, what we can do, we can manually go and increase the DTM buffer size. So I can just go and say like 1000 MB or something. Okay, so I can say that. But this is really not recommended. Okay, similarly I can change the default buffer block size also. So all the records will be processed in terms of blocks. So for that buffer block, I can provide the size. Again, it will be a auto. But in case if you really, okay. So DTM buffer size. The second one was default buffer block size. Even this can be changed. Where it will be? It will be in the config object default buffer block size. It will be auto. I can give any memory also here. I can manually provide the memory size here. So, but these are not recommended. As I told, in case whatever the default memory it is allocated, in case it is full, it is completed fully, then during the runtime only integration service will allocate the memory again. For that, it might take some time. So if you don't want to do that, you can give more memory size here, but it is not really recommended. That is one more option. Okay, this is at the session level. And the last two things are on the partitioning and push down optimization. So as I told, these two options are not available in our standard edition. Even these things will be used for performance tuning. So again, push down optimization, we don't use it really because it has its own limitations. Okay, but partitioning again we can use it. So what happens is when I extract the data from a source, wait a minute, 1 second. Say this was my log, right? It was saying created thread created for the partition point. What happens is I can create partitions for my work in my sessions mappings also. Same like in database partitioning, we can create partitions at my in my mapping also. When I create the map partitions, what happens? By default, integration service will create one partition for you. So for that one partition, we'll have one reader thread, writer thread, and transformation thread. Likewise, I can create multiple partitions. So if you create two partitions, then it will create two reader thread, two writer thread, and two transformation. So assume like anyway we will see this two features in Sunil's Informatica tool. Since it's a licensed one, we will have this feature in later, maybe at the end of the course and all. But as of now, to give you a background on partitioning, so assume I have mm, how many records? Okay, assume I have 1 million record. Okay, I have 1 million records in my source. Okay, when I was extracting the data, I got to know that this workflow was taking me sorry 60 minutes to extract the data and do some logic and all. So what I can do, I can create partitions now in my Informatica. Assume like I create three partitions. By default, it will be one, so I add two more. Then what happens? These 3 million records, it will be extracted in part, like 33.3 million records will be extracted in first partition. Okay, then again the next 33.3 million records will be extracted in my second partition, and another 33.3 million will be extracted in my third partition. And most important thing is these three things will run in parallel. So three reader thread will be created: thread 1, thread 2, and thread 3. So these three will run in parallel. So it will the thread first reader thread 1 will extract 33.3 million. At the same time, concurrently, reader thread 2 will also extract the remaining 33, and the thread 3 will extract the remaining 33.3 million records. And this extraction, it happens concurrently. So obviously, it will improve my performance. Okay, same wise, while loading the data also, I can do that. If I have 1 million records, I want to load it, it was taking 60 minutes, then I can make first to load the 33 million records in one writer thread, remaining 33 million records in another writer thread, and remaining 33 records in another writer thread. So then for this case, I can create the partitioning at my source. Partitioning point I can create at my source level. For here, I can create a partitioning point at my target level. Same wise, I can create the partitions for my transformations also. Within the transformations, I can create the partition. So it will create how many whatever partitions are there. For those many partitions, it will create me those many transformation threads. So in Informatica, we can create max 64 partitions. Likewise, at max we can create 64 partitions. So for each partition, it will create me three threads: reader, writer, and transformation thread. So if it is really required, if you really want to do some performance tuning, there is an issue with the performance and all, then only you can go for the partition.